in the previous slide I have previous 2-3 lectures I have discussed various classification possibilities. That is actually for if it is a coarse grained soil, we can do sieve analysis and hydrometric analysis, combining them I can classify the soil whether it is sand, whether fine sand, coarse sand, gravel sand, all those things. Similarly, if it is a fine grained soil, I can do the consistency limit test and then finally put it in a plasticity chart. And how to use this plasticity chart for classifying the soil I completed, I just explained in the last lecture. And now I know all classification. Now suppose as a geotechnical engineer, and suppose someone from the site one bag of soil sent to me, and I have to classify the soil. And how to do that? So, that I have to step by step I can show when the combine there how to do that I will discuss. So, this classification system, what system actually classify? One is actually grain size plasticity chart, something we do, and in addition to that actual classification means some different countries will have different standard. The Indian also standard is there. So, based on Indian standard, what is the classification procedure? Let us see that the Indian standard classification system, the grain size analysis can be done both sieve and hydrometer, and plasticity chart can be used for this purpose. And finally, doing these all those things, combining them, we can conclude with a symbol actually, and that symbol, a 2-letter system is there for classification. First one define the soil type, and second letter defining the subgroup. And example is like this: SP, and one soil is classified finally as SP. What it means? It means poorly graded sand. So, first letter is giving the soil type. So, that is why I am using the sand is the soil type, and second letter is the subgroup. What type of sand it is? Poorly graded sand. So, this is a subgroup, poorly graded is a subgroup. So, SP poorly graded sand, that the first one, what it is? It is a sand. What type of sand? It is a poorly graded. So, first letter will be define the soil type, and second letter giving you the subgroup. Similarly, SM, it is a silty sand. What it is? It is a sand, and what type of sand? It is silty sand. That means what? It is sand mixed with some amount of silt. So, that is the way actually finally you have to classify, and there are some steps that I will discuss one by one. So, these are the symbols or letters we use in the 2-letter system, prefix and suffix of Indian standard soil classification system ISSCS. So, soil type define the soil type by this letter. Gravel is defined by G, sand is defined by S, silt is defined by M, and clay is designated by C, and you can see silt and sand both are a first letter is, we are using mostly first letter. Sand and silt both are having first letter is S. So, sand actually it is universally all over the globe, actually sand is used as sand S, and silt used for M, and clay is C, and organic soil generally O, and peat, that is actually PT. Though these are the basically we are using first letter, gravel, sand, clay and organic all are first letter. Only for clay we are using, sorry, only for silt we are using M, and for PT instead of one letter we are using 2 letter P capital and T small, pit, so in small abbreviated. And subgroup actually letters, actually well graded generally W, we use well from their first letter only we are taking, poorly graded P we are taking, and silty, that again silt is M, here also to represent silty M we are use, clay is used C. So, here to represent clay subgroup the C, and Then again organic can have low plasticity and intermediate plasticity. So, low plasticity is one when water content or water that is plastic limit liquid limit is greater than 35, then this is low plastic and that is designated as L, and when it is intermediate, that means liquid limit between 35 and 50, then that is used by I, and Wi, that means it is greater than 50% than peat. Organic, and what is the difference between organic and peat? Peat is a fully decomposed, that is what that organic clay, then it will be highly plastic. So, that is liquid limit is greater than 50 and it is used by letter H. So, W means here W means well graded, P means poorly graded, M means silty, clay means clayey, L means low plasticity, I means intermediate plasticity, H means high plastic. Similarly, soil type G means gravel, S means sand, M means silt, C means clay, O means organic, PT means peat. So, like that these two letters in different combination to be used to name the soil. Steps in soil classification you can see determine. So, first of all you have to, if the one bag of soil comes, as I have mentioned a few minutes back, that if the one bag of soil, then whether you will start doing sieve analysis or do something. So, that there are some steps. So, the steps are that whether first of all you have to examine what type of soil, if it is whether it is organic or not, that to be determined first. Determine whether the given soil is of organic origin or coarse grain or fine grain. These three things first of all initial inspection we can differentiate. An organic soil will be identified visually by its color. Generally it will be dark color and brownish black or dark, and it is characteristics odor. There will be smell also, and organic color clay there will be smell. So, first of all you have to initially whether you have to find out it is organic clay or coarse grain soil or is a fine grain soil. If it is organic clay, treatment is separate. If it is a coarse grain soil, sieve analysis. If it is a fine grain soil, then it is plasticity analysis. These three things you have to do. Next is next step is if 50% or more of the soil by weight is retained on the 75 micron sieve, it is coarse grain. That means more than 50% retained on 75 micron, then it is coarse grain. If not, then it is fine grain. So, that is the thing to be considered. Next step is if the soil is coarse grain, suppose it is more than 50% retained by 75 micron, then you have decided it is a coarse grain. Then coarse grain soil, if it is coarse grain, immediately what is our next action? Next action will be obtain the GSD, means grain size distribution curve from sieve analysis. If 50% of the coarse fraction again is retained on the 4.75 millimeter sieve, classify the soil as gravel. That means 75% retained soil, 50 more than 50%, that is the test we have done. But based on that we have decided it is a coarse grain. Now, that coarse grain soil I am trying to do GSD, and when we find that again more than 50% is retained on 4.75 millimeter, then the soil itself will be classified as a gravel, and if not, if it is more than 50% passed through that, then this to be classified as sand. And if the soil fraction passing through the 75 micron sieve is less than 5%, determine the gradation of the soil by calculating CU/Cc from the GSD curve. So, that means first step what we have done, we are checking whether passing through 75 micron. If the passing through 75 micron is less than 5%, then what you have to do, it is a sand type of soil. So, CU/Cc etc. will be calculated, and based on that we can classify the soil as like well graded gravel, well graded sand, poorly graded gravel, poorly graded sand, like that. So, classification can be done based on that if it is less than 5%, and if the more than 12%, if more than 12% passes through the 75 micron, that 75 micron process material, if it is more than 12%, then perform liquid limit test those passing material or soil, and liquid limit plastic limit test on the soil fraction passing through the 425 micron sieve, and use the plasticity chart to determine the classification. And finally, that this type of classification can be done combination of a gravel and presence of gravel in addition to whether it is clay or silt, that from the plasticity chart can be there, and that combining them we can classify the soil like GM, SM, that means silty gravel, silty sand, or clayey gravel or clayey sand, like that we can classify. Now, if the between 5 and 12% fine particles, less than 5% only grain size distribution the CUCC all calculation, between more than 5% you are doing plasticity and doing this type of analysis, and if between 5 and 12%, then again the soil is assigned a dual symbol appropriate to its gradation and plasticity characteristic. Again that passing through 75 micron, that has to be grain size distribution based on that, whether this is poorly graded sand or well graded sand, that is there. In addition to that, plastic material also, whether it is silty or sandy or all those things, this dual symbol, that means 4 letters will be there. One is sand, another is again clayey sand, this type of dual symbol to be used. If the soil is fine grained, then determine liquid limit, plastic limit on the soil fraction 425 micron sieve, and determine the plasticity index. And now, the fine grain actually, that means more than 50% pass through 75 micron, then it will be treated as fine grain, and then you have to do pass through 425 micron, take that soil and do the plasticity test, and after doing the plasticity test and do plastic limit and liquid limit and plastic limit, and refer the plasticity chart where there is a line, one side is the plasticity index, one side is liquid limit, and then based on plasticity index and the liquid limit plot particular soil you have tested, you will get a data set, the Pi and LL. Pi and LL you can plot in a plasticity chart, and you can find out the presence of point with respect to a line, whether it is above a line or below a line. If it is above a line, then the soil is clay or plastic, and if it is below a line, then soil is silt or non plastic, moderate plastic, silt can be plastic also. Further, if liquid limit is less than 35, classify as ml, and liquid limit. So, if the limit plot the a line, plot a line, if the m below a line, actually some line a point is missing, a letter is word is missing. If the liquid limit is less than 35, classifies as ml, if liquid limit is between 35 and 50 as mi, and liquid limit is greater than 50, classified as ml. So, if the limits plot below the a line, here actually something missing. So, below the a line, if it is coming below the a line, which I have shown before, below a line all are silt and above a line all are clay, and if again less than what liquid limit less than 35% is something, that is actually silt of low plasticity, that is ml. If the liquid limit between 35 and 50, that means silt of intermediate plasticity, that is mi, and if it is greater than 50, that means H, that means silt of high plasticity. And if the limits plot above a line, that is the thing next step, the a line the point comes above a line, then classify as clay, and assign the group symbol Cl, Ci or Ch depending on the value of liquid limit. That means, if it is less than 35 liquid limit, then Cl, if it is between 35 and 50, that is Ci, and if it is greater than 50, that is Ch. If the limits plots in the hatch zone classified as Cl and Ml, if the limits plot close to the A line or close to the liquid limit 35% or 50% line, assign dual symbol. That is, if it is very close, these are the decision and can take as a geotechnical engineer. So, this is about the steps in classification. If the soil has 50% each of fines and coarse grain fraction, both are 50-50 equal. In that, what to do? Determine whether the coarse grain fraction is gravel or sand. Determine liquid limit and plastic limit on the soil passing 425 micron sieve. Then determine whether the limits plot above the A line or below A line, classify as C or M. Based on liquid limit, classify as whether it is L, I or H. Assign the dual symbol from the information obtained in above steps GMML, GMMI, etc., etc. So, that means, if 50-50, you have to do both, and then finally, you have to take this type of classification. And next is when there is a granular soil, then sometime granular soil can be classified another way, that is by relative density. And what is the relative density? The expression for relative density is given here. This expression is given of relative density, and relative density universally it is used a notation dr, and that expression dr related equal to E max minus E divided by E max minus E minimum. What are those actually? E max is what? The soil, when at a particular soil, suppose collected from a soil from a site, what could be its maximum void ratio? E max, E is the void ratio. This is also universally used everywhere, void ratio E. E max means the soil which is collected, what is the maximum possible void ratio of the soil, and when actually we can expect the maximum void ratio in the soil, when the soil will be in the loosest state. That means, when you collect sample from a site, we can pour in a container in a loosest possible state, and from there we can find out density, and from density we can find out the void ratio, that will give you the E max. Similarly, E minimum means what? The minimum void ratio of the soil. How we can get? The same soil, when it will be in the densest state, if you keep in a densest state, then the soil will have the minimum void ratio. And how to get this minimum void ratio? That means, if you, whatever soil you collect from the site, that soil can be poured in another container again in a densest condition. There are some procedure IS code has given how to do that to achieve loosest state and to achieve densest state, and from there you can find out E max and E minimum. In fact, you can find out density gamma max and gamma minimum. From there you can find out that E max and E minimum. And also, and what is this E? E is actually is the field void ratio. So, if you know the field void ratio and if you know the soil type, then we can determine the E max and E minimum, and putting in this expression I can get a number which is in percent, finally can be expressed, and it will be vary between anything between 0 and 100, but 0 cannot be achieved. 0 means nothing is the all voids, and 100 means there is no voids, but both are impossible. 0 voids also difficult to achieve, and without any voids also is impossible to achieve. So, this is the relative density, and this relative, based on this relative density, the soil or granular soil also can be classified another way that is given here. This is the one, the state relative density less than 15, then soil will be classified as very loose. That means, if the soil at a particular site sand is there, then what type of sand? It is a very loose sand, if it is less than 15%. Similarly, if the relative density, that means you collect the sample, find out the minimum void ratio, find out the maximum void ratio, find out the in situ void ratio, put it in the expression, finally find out this finally find out what this value of relative density dr, if falls between 15 to 35, then the soil will be treated as loose, that means loose sand. Similarly, if that value comes between 35 to 65, the soil will be classified as medium dense sand or medium loose sand. Similarly, if the value falls between or the percent between 65 to 85, the soil will be classified as dense sand, and with this and if it is greater than 85, then it is called very dense. And in fact, very dense, beyond very dense, actually the achieving beyond very dense state is very difficult. And another thing is the amount of effort required from improving the relative density, suppose from 15 to suppose 30, the amount of you are increasing the relative density suppose 15%, but effort required to change this much of relative density, the amount of effort required. And if you suppose another relative density 70 and changing to 75, one is suppose 15 to 30, the effort required here and effort required here, the effort required here will be much bigger than this. So, that means looser side to improving the soil is comparatively less effort is required, but when it is a denser side, the improving by 1 or 2% effort required extensively very high. So, this is the one sort of state, that means if you find in a particular site the soil is in this state, then we can actually find out your state of the soil, that means whether it is loose or very loose or dense or very dense. So, like that with this by and large actually I am completing the my origin and classification module, that means how the soil and how we understand by different people, and then before soil we find what was the state and how that state to soil is transformed, and then after getting the soil, how the we can classify the soil again based on the different types of soil, like whether it is granular or it is cohesive, if granular something, if it is cohesive something else, and then based on this classification, actually once you know the classification, though as I have told at the beginning that we will understand many things qualitatively. For example, I am telling once again that if it is a soil cohesive soil, then the soil your will be highly compressible, strength will be compressibly less, and permeability will be comparatively less. And if you find suppose granular soil, strength will be comparatively high, it will be settlement will be comparatively less, and it will be highly permeable. Again some classification we get, suppose some soil classified as CI or CL etc., based on that also which soil will be settle more or less, that also we can get it. So, by classification of the soil, to understand the soil, by understanding the soil, we can guess some quality or characteristics of the soil, but ultimately when you design something, we need some quantity. What is the strength value? A number is required. Similarly, what is the permeability? A number is required. How much it will settle? That is number is required. So, to find out those number, now we will do different analysis, different mechanics we will use, and subsequently one by one we will treat those sections. With this, today I will close this classification. Thank you.